Hello everyone, get this thing out of here. Welcome back to Handmade Hero, the Mac OS platform layer. I'm just doing it because I figure there might be some people out there that would want this. And we are actually at day number 4, so we're following along, trying to follow Casey's series as much as possible, but just assuming that you had started out on a Mac instead of a PC. And I actually realized that I have made a grievous error in the last stream, or not really stream, but just video. And I neglected a very important property in the window where if you don't set it, you're kind of screwed. And the reason I know that is because I actually just tried to record a video rendering the buffer to the window, and it did not work, and I probably spent about 20 minutes puzzling through it, but thankfully you don't get to see that part. So before we start anything, what I would like to just mention is this bit right here, window.contentview.wants_layer equals yes. I'm going to put that in the article for day number 3 as well, but just so you know, this is very, very important. If it is not set, then it doesn't matter what you do with this NS bitmap image rep or NS NS image. None of that stuff's going to work. So now I will collect myself and kind of come back and and actually work through some of this. So here we are. We've got this buffer that's been allocated, and the buffer represents the stuff that we're going to draw to the screen. It is aligned in kind of these 8-bit unsigned integers. And what that means is that each individual 8 bits actually represents not a single pixel, but rather a pixel channel. And by that I mean that a single pixel is like 32 bits in memory, but it is actually comprised of 4 different channels. So it's got a red channel, a green channel, a blue channel, alpha channel, and each 8 bits is going to represent the value for any individual color channel. So that's kind of where we're going with this. This is actually on the Mac. It's actually laid out a little bit differently in memory. So on the Mac, or at least the way we've done it. Now it could be different if we weren't using this NS bitmap image rep, but right now the way we're doing it is actually red, green, blue, and alpha. And so the reason it works that way is because we've set that RGB as the color space. And another reason that it works that way is because we've also said that it's got alpha. And so now I don't actually know what it would do if we said it doesn't have alpha. So that's sort of an area where I'm not 100% certain. Maybe the rest of that would just be padding. I'm not really sure, but just kind of something to consider. So we've got that, and that's how things are going to be laid out in memory. But what we ideally want to do here is start kind of traversing through this buffer. And the way we want to do that is understanding what a row is and where a row starts. That's going to be really useful. And this is actually where the pitch kind of comes into play. But we're going to use this kind of like this sort of nested for loop, where the outer for loop is actually going to be stepping through each individual row. And then the inner for loop is going to be stepping through kind of each individual pixel channel to go through one row. So if you can think of it this way, so we're going to have, first of all, let's just kind of simplify it where we've got, we'll do this up here since we don't, int width equals bitmap width. You probably don't need to do this, but it's fine. And height, bitmap height. And then, so on the y-axis, we're going to go, so we're going to say for int y equals 0, and then y less than height, and then add to y. And then for the x part, we're going to go int x equals 0, x less than width, plus x. All right. All right. So that makes sense, right? So y is going to be handling kind of the height of it, and then we're going to go through the width. We actually want to start out with a pointer to the row. So we'll say that the start of the row is actually an unsigned integer 8 pointer, 8-bit unsigned integer pointer row, and that's just, we're just going to cast buffer to that. So we're saying that this row pointer starts at the start of the buffer, okay? Which kind of makes a lot of sense. And then every time that we go through this, the row kind of loop, what we'll do is we'll actually add, the pitch to the row. So, and then remember that the pitch is actually like the number of 8-bit unsigned integer spaces that represent the width. So if we go all the way back up here, so number of bytes per pixel, well, there's 32. So there's 32 bytes, no, sorry, 4 bytes per pixel, so 32 bits though, times the width of the thing. So what this pitch is going to do is just adding pitch to the row pointer will actually get us to the next row. And so that's kind of what this is doing here. This is getting us to the next row. Okay, so that's kind of stepping through that part. But we also want to step through the individual pixels, or I don't know that you could call it pixel, or you could call it, like, I would call it something more like pixel channel, maybe would be like a better way to put it. So pixel channel. And then it's just going to be unsigned integer 8 row. And then, yeah, so that's going to, every time we start, the beginning pixel is going to start at the beginning of the row. And then kind of as we go through here, this is where we're actually writing to the pixel channels. So blue, green, I don't know why I keep doing that. Red, green, blue. And then finally alpha. All right, and so now in order to actually write to a pixel channel, you want to dereference the pointer. And so dereferencing the pointer is just putting star in front of it. So star pixel channel equals, let's say we want the red to be like 255, right? And so what that's going to do is it's going to write the maximum possible red value to that particular pixel channel, which in this case is going to be like the very first pixel channel in that row, and then it's going to kind of, you know, go along. So now, and so like dereferencing just means not actually, because pixel channel is a pointer. So if we were to write that to the pointer, then that would mean like that's like saying that the address is somewhere in memory, that would cause a problem. But dereferencing means that we're actually going to write to whatever is in the address that thing points to. So for those of you who aren't, I know some of you are probably coming from like maybe Objective-C or Cocoa, and so it's really usually not too common that you would even need to do something like this. But this is kind of like what you would do in C. So now we're actually writing to it, and then if we increment that pointer by 1, let's just do it this way. So since it's a pointer to an 8-bit unsigned integer, what that's going to do, incrementing it by 1, is actually throws us into the next kind of pixel channel. So we can definitely use that. And I don't think I want green to have any value right now, because maybe what we want to do is just see if this is working. So do that. And then, oops. Not what I wanted. Still learning Vim. That's so funny. Okay, so on Vim, by the way, I hold I do V and then P will paste. So that gets me there. And then, all right. Making some progress. Yank that. All right. Now, it's really important that the alpha channel be set to something, because if it's not, that is going to it's going to make some problems for us. So here, if our alpha channel is set to 0, then nothing's going to render because, well, the alpha is 0. It's transparent. So setting it to 255 means solid alpha channel. Definitely render everything. So see if we got everything that we wanted, and I think we do. So what you can expect from this is to just see a red window. So let's see if we'll compile here, and then kind of build and run. So nice. So all right, and now you see we've got a red window. So there's no kind of like unintuitive or like strange, because I know in Casey's video it starts with a blue one, but actually because we're on the Mac and because we're using this NS-bitmap image rep, we can actually just write to the straight to red. The first one's going to be red, so that's kind of cool. Let's close that and go back into this. All right, so, oops. Now, what we want to do, so we've tested the red channel. We know that works. So let's definitely test the green channel. So we will just do 255 to the green channel. All right, and let's do that. All right, we got green. Nice, kind of like line. Cool. All right, we know that works. All right. Okay. Set that to 0, and then we're going to try out the blue channel. Set that to 255, and then quit, and then do that. And we got blue. So now we've definitely tested all of the channels. That's pretty neat. Cool to be here. So while we're at it, let's kind of play around with this a little bit more. So all right, so we know that these channels work, and we know that. So if I look at this, let's set this to. Well, let's do what Casey does. I think what he does is he I forget if the green is the X or the Y. Well, let's find out. So what we can do is we can make each of these. So if we take the Y value and cast it to an unsigned integer 8. 8-bit unsigned integer Y, and then let's do that with the X as well. Okay, so green and blue, yeah, so what's this gonna do? As the X goes up, then it's gonna get gradually more blue, and then it's gonna drop off, and get gradually more blue, and then drop off. And then similarly with Y, it's going to gradually get more green and then drop off, and gradually get more green and drop off. So let's take a look at that. I think this is what we have, or something similar to what is, yeah, I think this is actually it. Um, obviously, like, kind of doesn't matter, but the idea is like, so each of these squares kind of represents sort of an iteration through that loop. Because remember, well, in 8-bit onsite, and they have to be, by the way, 256 by 256 pixels. That's why you get this square pattern, is because it starts at 0 and then it goes up one row, and then like on each of one of these, it's adding to the blue until it overflows, so it goes over the maximum value. And when you have an 8-bit unsigned integer, it can't store more than 256. Individual values. And so what happens if when it goes over that, when you add to x again, well, it goes back to 0. So it goes all the way up 0, all the way up 0. Just for those of you that, I mean, it's entirely possible these days that you could have been programming like iOS apps or whatever, or websites, and like not know that. So just kind of little bit of computer science 101. So how we interpret some of those things. But this is pretty cool. We've kind of got this like interesting pattern here going on. There's, maybe we'll have a little bit of time for this, but there's and I don't even know if Casey does any of this, but notice like there's actually some kind of funkiness if we, if we like resize this, it kind of acts a little bit weird. So what's up with that? That might be something like kind of worth looking at. So we might want to take a look at what is happening there. And my computer is starting to kind of, the fan's going. So that's pretty cool. Some other things that we could do just for funsies. So if you wanted to, like, you could also, we could make like an X offset. So we could go, like, let's just say that, int offset X equals 0. And then what we would do is, so we would take like the blue channel, right? And then we would say that its value is actually X plus, oops. Let me take this, oops. No stars. Offset X. Okay, so what's going to happen there? Now we want to like probably add something to the offset. So like maybe write, like at the end of this section here. So we do that. So that's just going to keep incrementing it. And if we do that, then all right, cool. So we've actually got kind of an animated backbuffer. So what's going on is like every time this thing runs, what it's doing is it's actually like, it is adding some to that X offset. So that's pretty cool to know. Now, why is this thing squashing? The reason it's kind of getting squashed like this is because we're not really handling like resize events properly. And by that I mean when the size of the window actually, because remember we calculated the size of the buffer at the very beginning before the main run loop. And so what that means is the size of the buffer is not really getting refreshed. So that's like semi-problematic, I guess. Obviously, like there's no actual behavior that we're trying to define. We're just sort of like writing to the screen right now. But we probably would want some way to refresh the buffer. And so by that I mean saying, if the window changes, that's kind of like that's an important, or the window size kind of changes. That, to my mind, is a fairly important event that we would want to keep track of, and we would actually want to make it so that this thing changes the buffer size, and then maybe another thing that would happen is the image that gets allocated would also kind of be different. So that would be something worth considering doing. So let's definitely do that. And the extent to which we'll spend time working on, what I want to do actually is do like a day 5 that's actually just like a little bit of cleanup, because some of the things that we can do, for example, we can actually take this code right here, like this handmade window, main window delegate. Maybe what we want to do is move that into a separate file, just because if we, it's kind of like out of the way. So that's a possibility. Move some of these like Objective-C things that we are looking at doing. So, okay, so we want to be able to, well, let's look at it a few ways. So first thing, this is kind of our code where we refresh the buffer, right? So this is where we say, this is definitely where we're gonna like make a new buffer. So I would say that we want something like, let's just put it right here, right before our main. So just void refresh buffer. And I think that it needs to take a pointer to an NS window. So take an NS window pointer. And what's one kind of cool thing to note for those of you who are mostly, Mac developers, so you can actually do this. You can actually just like pass Cocoa objects to C functions like this, and it totally works. So it's kind of a neat thing to know that you can do that. So what we're actually going to do here is then, I think we should make the bitmap width and the bitmap height global variables. So let's go and do that. So let's do width and then the height. Okay. And then that's kind of where we will do the refreshing. So let's actually just kind of yank that bit of stuff here, because what we're going to do is actually just call this. Okay. So there's that. Yeah, and then what we'll do is we'll just call refresh buffer here. So that way there's, at the very start, there will be kind of one point where we refresh the buffer. And then there's let's see, bytes per pixel, I think, could also just be like a constant sort of global variable. Why not? And by the way, like, when I say global, don't freak out, because we're only in one file. This is like, it's not permanent. None of this stuff is actually going to be the way that this platform layer actually like works when it's done. It's just that when you've got like relatively little code, and you can do some of these things, so you can make things global. So we'll do global variable int, is it bytes per pixel 4, right? And what's nice there is we can just kind of get rid of that. And then let's make the pitch global variable as well, just because I think we'll be using that. Oh. I think that's integer. Okay. And we'll just take that. We'll actually take all this stuff out. And we'll put that into the refresh buffer. Okay, and we can get rid of this. So there's that. All right. Now there's one really important thing here worth kind of mentioning, and that is the memory management situation has changed. So by that I mean in the previous one, what we had done is we never needed to free the buffer. Okay, we just kind of we declared the buffer once before the main run loop, and the reason. And so we kind of allocated whatever that was, whatever kind of matched the window sort of before the main run loop. But if the window size can kind of change and the buffer can kind of change, and we're going to keep kind of calling this over and over again, every time you call malloc like this, well, there's this possibility that we're going to like leak the buffer. So we don't want to do that. So we just need to make sure that if the buffer exists, then we just free it. So if buffer, free buffer. So we'll free it right before we ever, right before kind of allocating it again. And the reason that, by the way, so the reason that it was never important for us to free the buffer earlier is because we only declared it once before the main run loop. We were never allocating more, so it would only allocate it once. And then once you exit the main run loop and the app is kind of finished processing or just finished running, at that point in time, like everything's like taken out of memory, so the OS like cleans everything up for you. I think, let's see where we are. That's our refresh buffer function. And so we're going to call that. All right, good, very good. Okay, so refresh buffer takes a window. All right. Now this kind of thing can definitely help, but I think what we also want to do is sort of extract out the code that renders that gradient, or as Casey calls it, like the render weird gradient method. We definitely would want to do that. So let's do that. And what's really cool, so the important thing void render weird gradient. And whether you pass the x offset or not, it's kind of up to you. I feel like we'll just make the x offset. I don't know. Let's make it global because that way, when the window gets resized, it can just refer to it, and we don't have any weirdness. It's a little bit different than the one in the PC version because just with the way that window resizing works, it's not quite the same. You kind of have this like delegation stuff going on. But anyway, so important thing to note about this render weird gradient function is it is, shall we say, platform independent. Whereas the refresh buffer method, or function rather, not method, the refresh buffer function is tied to the Mac OS platform. It takes an NS window. Like, that's just how it is. It needs the NS window because if it doesn't have the NS window, then it can't figure out like how big the buffer is going to be. But this render weird gradient thing just kind of assumes that we have a global buffer, and the buffer is platform agnostic. Like the buffer doesn't care what platform it's running on. It's just some chunk of memory, right? And so this is like ideally how you make something platform independent. It is like now we're down to like the raw memory. Any system that's going to be doing this is going to be operating on memory in more or less the same way. Not exactly the same way, but it isn't purely like platform independent, but it's close enough to being platform independent to where we could say, that it is. It's just something kind of important to know because later on when we start actually moving the game kind of into its own separate realm, then that particular method will be taken over into the platform independent stuff. So what we're going to do is we're just going to take this giant for loop code here that's writing to the pixel buffer, all right, and we are going to just paste it up there. And this is the render weird gradient method, okay. And I'm just going to like be all nice and tidy. One thing I love about Vim is being able to just like get this stuff to move over just using the visual. I don't know, it's pretty cool. Okay, so remember that a lot of these things are still global, so the buffer is global, so we should be able to kind of keep doing that. And one thing that we will definitely do is just make sure that some of this stuff is. So I think we need that actually. So we will actually recalculate the width and the height using bitmap width and bitmap height. Okay, so that is that. Okay, so that's looking pretty good. And then what we need to do is make the x offset global. So let's do that. Yeah. Yes. Okay, 1GG. All right. You will see at the end of this, I will be like super proficient in in Vim, and I'll be able to do this pretty fast. I think we shall see. So, all right. So we got the x offset, and we want that to kind of start off at 0. And we don't now because yeah, we don't need to have this. So delete the word. Okay. All right. And here, this is where we would call the render weird gradient method function, not method. Sorry. When you're brainwashed, object-oriented programmer, everything's a method. So you don't actually spend a bunch of time just in. Okay. Now this should do this. So this is like just kind of a good programmer instinct is when you've moved enough stuff to kind of like know when to stop, and because otherwise like then you'll have like a million errors, and it's like what we should do is just like see just like a quick sanity check. Does it build, and do we get kind of the same are we at, shall we say, feature parity? So do we have the same amount of features? And the answer is yes. We just move stuff around. Obviously, this like weird distortion thing is still there, but that's fine. We can live with that. So, all right, so we go back into that OS 10, OS X main. Okay, so now we've made all this stuff global. We have this refresh buffer method, and we've actually extracted out render weird gradient, so this is looking pretty good. Now, another thing that we will want to do is extract out this this thing right here. So I don't know what, I kind of call it like, refresh image, or, redraw buffer, shall we say. And an important thing to note with this like redraw buffer is this is actually not platform independent. It definitely requires knowledge of the platform, but so just something to know. So, and maybe maybe what we should just call it is macOS redraw buffer, ns window star window. Okay, and actually like just to be kind of pedantic, because this is also not platform independent, so I think we should just call it macOS refresh buffer, because that way we know, when we're calling it, that it's a macOS function. It's really only meant for that platform. And this kind of naming is going to be really important later on when when we've got, so Casey starts on, Windows Win32. We're starting on a Mac. But when we, eventually, like as you make this, the only reason I'm starting on a Mac is because I'm cheap as hell and I don't want to buy a PC yet for whatever thing I'm working on. But when I, decide that I'm not going to be cheap as hell and I'm actually going to like, because I've got some game and people like playing it or whatever, and I like want to, support the platform, and I go and buy a PC, then at that point, it's going to be really important that all of my Mac OS code was properly named Mac OS such and such. So, anyway, bit of a tangent. So we want to just definitely like copy this and move that all the way back up to this macOS redraw buffer. So definitely making some progress here. And this can just pretty much be the same in here because a lot of this stuff is now it's global, so we don't really have any issues there. Chugging along. All right. So yeah, so Mac OS refresh buffer, and then yeah, so render weird gradient, and then Mac OS was it redraw buffer? I think so. Okay, I think it was Mac OS redraw buffer. That could be right. Yeah, it is. Okay, so Mac OS redraw buffer. Sweet. Yeah, let's quit this and then let's build and see if we got any errors or not. Okay, are we at feature parity? Hopefully. Feature parity, very cool. By the way, Control C will just quit out of it if you don't know. All right. So now we've got kind of the sort of the three horsemen functions that we want in order to be able to handle like a window kind of a change. So that's pretty cool. Let's definitely do that. So these sort of three functions here are pretty useful. Now, remember, the way we got this window to close, or the way that we were able to kind of like make our run loop bail on us, was by creating this handmade main window delegate object. So that's sort of like kind of the Mac OS way of doing that is we create some kind of thing that's like a subclass of NSObject, because every class in Mac OS and also, well, I think no, just generally Objective-C has to inherit from NSObject. And if you want anything to adopt a protocol in Objective-C, then it has to be some kind of a class. So in this case, we made a class that that adopts the NSWindowDelegate protocol. And one of the methods in this NSWindowDelegate protocol is this window will close. And so I think one of you, I definitely was reading one of the comments from one of you about, kind of how do we do research for some of this stuff. And a lot of it is just, I always like look up just the class reference for something. But so, NSWindowDelegate will get us kind of all these things, all of these different methods. But, literally like walking the tree for some of this stuff is really quite useful. So understanding sort of like the inheritance hierarchies of stuff. So if I was to go on to like NSWindow, okay, well, this is kind of an interesting thing. So these are all the like properties and methods and stuff that NSWindow gives me, and that's good to know, definitely. But there's also like hidden stuff, because this is very object oriented, and what that means is there's like this hidden hierarchy of inheritance going on that you wouldn't know right away. So an NSWindow actually inherits NSResponder. So if we want to know there's all this like NSResponder stuff that is a part of NSWindow that's not like explicitly going to be in this documentation here. So what you actually have to do is click on this NSResponder, okay? And now like NSResponder's got like all of this stuff. All right, and so like, you know, maybe the thing you're looking for is in there, but like that ain't it completely, because NS responder also, like, there's three kind of tiers of inheritance going on here. NS responder actually inherits from NS object, and so we got all of this. So it's like, you can imagine this like, you know, this kind of pyramid of stuff. Like there's and it's like, this is about as like heavy-handed as it gets. So you got this, like, you know, NS object at the very bottom, and then at the very top is like kind of your NS window and the stuff that you want. So I'm just kind of saying this because one of you asked, like, okay, you know, where do you get some of these ideas, or like, how do you know where this stuff is? And it actually just comes down to like understanding, first of all, that there is sort of this inheritance hierarchy that's going on in most of these Cocoa classes, but also that, so like, let's say I click on, you know, this thing right here. So this property, image title, all right, of NS object, it is an NS string. And so if I wanted to know about that, then I would click on that. And, you know, again, an NS string inherits from NS object. And, you know, we're like back around the around the loop we go. So that's just kind of something important to know. I know, because I know one of you had asked about that. So NS window delegate. Got all these things. We've gone over this before, and the really important one we want to know is window. It's like window will resize or something. Where is it? Window will close. Window will move, did move. Window did failed. No, didn't want that. Exit full screen. Should zoom. Miniaturize. Window did resize. Okay. All right. So again, just kind of like an important thing to know. So it tells the delegate that the window has been resized. So anytime that you resize your window, what's happening is that your handmade window delegate will then call this method should we choose to implement. If we opt into handling this, then our handmade window delegate will decide to properly send this stuff to us. So always read these kinds of things, because so one of the things you'll notice here, and this will be kind of a great like little instructional thing about how to like walk Apple's class hierarchy and kind of learn this stuff. So you can retrieve the window and object by sending object to notification, which is a little bit weird, because Objective-C is kind of this like message sendy sort of like thing. What does that mean? Well, window did resize passes in an NS notification parameter. Okay, so an NS notification's got a bunch of stuff. Again, you know, class hierarchy. We don't need to know about its NS object-y stuff, but it is, you know, it inherits NS object as everything else does. But the important thing to know is that every NS notification has this object property. So that's good to know. But then also what this documentation is telling us is you can retrieve the window object in question by using the object property. So what you can do is you can take the notification object and you can actually cast it to NS window to get the window that resized. So we're going to do that. So we will just copy this this code here, and that's actually going to go into our into this like sort of handmade window delegate thing. Okay. All right. All right. I don't know why okay. So now we want to get the window, right? So we want like a pointer to an NS window, right? And actually what you can do is you can just cast the notifications object to NS window. So notification object will return a pointer to an NS window. And now what we can do is we can actually call all of those same methods that we were using before, just passing it the window. So we can do, I'll just kind of copy all the same stuff. So we can call our, yeah, we'll just do these two, and okay. All right. Okay. Oh, come on, Vim. Ah! All right, something's wrong. Oh, that's because they're not over by 4. Okay, well, all right. I'm changing this. I changed the way this thing works. So, so now we also want to call our refresh buffer. And by the way, if anyone wants to, give me like a comment or whatever if you want. Oh yeah, that's right. macOS refresh buffer. That's right. If you want to have a tutorial on Vim for this, it just would be kind of cool. Because I've definitely learned a few things, and that's sort of been my challenge with this, is to do a lot of the editing in Vim and just kind of avoid Xcode. Not necessarily because I think Xcode is a bad tool. I actually really like Xcode, but just to get familiar with something else. So we have this NS window, macOS refresh buffer. All right, so this should, what this means now is we've kind of opted into this window resize behavior, and we're gonna be able to get our window like that, and then this will refresh the buffer, so the buffer is gonna resize based on the new window size, and then it's gonna render the gradient with the new window size, and then, so it's gonna render the gradient in the updated buffer from the new window size, and then what it's gonna do is it's gonna redraw that buffer to the window. So we will quit and build. Oh no! Use of undeclared. Okay, got it. All right, so problem when you do this kind of thing. So we need to actually, what this means is I just need to move these functions before the declaration of handmade window delegate. And the reason for that is because I don't have them. So if I don't have them, or they don't exist before that. So the way this works is these functions need to be somewhere above the thing where they get called. So I'm not actually used to things working that way. But now, so I just moved them up to the top. Now that they're kind of above it, really shouldn't have an issue with it. So let's do that. All right, so that built. Handmade. All right, now what do we have here? So what's going on? Now it will notice that it doesn't increment, so the offset doesn't increase. But what you notice is that there's no more kind of stretchy stuff going on here. And then if I let it go, then the run loop kind of keeps going. But every time I drag my cursor and resize the window, it's actually completely, it's refreshing the buffer, and then it's redrawing it. So that's pretty good to know. Just kind of being paranoid, I do want to show memory just to be, okay. Yeah, and so this is kind of a cool thing to know. So look at this, memory, 11.2 megabytes. And this might be a little bit of an instructive thing. I'm hoping, cool. So what you see is that as this is kind of a neat thing to just, it's really cool to see this because it puts 2 and 2 together, right? So this buffer is just raw memory, right? And so the memory footprint of this application, right, it ought to change if we've actually got a bigger window. So if it's smaller, we ought to have a smaller memory footprint. And if it's bigger, we ought to have a bigger memory footprint, I think. Yeah. So that's like a really kind of a cool thing to sort of put together, and just actually see that in practice. Anyway, end of day 4. I really gravely apologize for my mistake on day 3. That once layer thing was just, and I spent like half an hour digging through a bunch of code, but I will change that that particular tutorial, and that'll be just fine. So here we are. I'm not actually gonna, because this has kind of already been pretty long. I'm not gonna go through all of the other formatting stuff that I did in the day 4 article. But we're drawing to a screen, which is really cool. We're drawing to the buffer. We're animating the buffer, just as in Casey's video. We've more or less left off at the end of day 4. And I think I will actually do a day 5 that's sort of like a cleanup day. That's kind of my thinking around that. There'll be like an article on it, and etc. I'm not sure how much cleanup we'll do, if we really will do that much. But I don't know. It might be instructive just for Mac apps in general, and kind of the Mac OS sort of environment, build environment, etc. But yeah, there we are. Pretty cool to see. So I'm still having fun, and hope you're enjoying this as well. And I will see you next time.